Everything you know, everyone you love, and every star in the sky is going to die. Not just die, but dissolve into a meaningless, uniform soup of nothingness. And the craziest part? The physical law that guarantees this total destruction is the exact same law that allows life to exist right now. It is the single most important concept in the entire universe. It defines the direction of time itself. It is the reason you can remember the past, but not the future. We are talking about entropy. And to understand why the universe is doomed, we have to start by debunking one of the biggest lies you were taught in school. What does the Earth actually get from the sun? If I asked you right now, you would probably say heat, or light, or energy, right? You'd be dead wrong. Let's break the physics of this wide open. Here is the reality check. The Earth radiates almost the exact same amount of energy back into space as it receives from the sun. If it didn't, our planet would boil over and we would all incinerate. It has to be a balance. Energy in equals energy out. So if the net energy gain is basically zero, what is the point of the sun? What are we actually eating? We are eating order. We are consuming low entropy. The sun sends us high-quality, concentrated energy in the form of visible light. The Earth takes that, uses it, scrambles it, and spits it back out as low-quality, spread-out infrared radiation. For every 1 photon of sunlight we take in, we vomit out 20 waste photons. We are survival machines that feed on order and excrete chaos. That is the secret of life. But to really grasp how insane this mechanism is, we have to rewind 200 years to the middle of the Napoleonic Wars. Picture this. It is 1813. France is crumbling. Armies are invading from all sides. A 17-year-old genius named Sadi Carnot wants to fight, but Napoleon ignores him. France falls. Carnot is devastated. He realizes that Britain isn't winning just because of soldiers. They are winning because they have better technology. Steam engines. The industrial might of a nation depended on how efficiently they could turn fire into movement. Carnot becomes obsessed. He wants to build the ultimate engine to restore France's glory. He goes into isolation for 3 years and unintentionally discovers the fundamental limit of the universe. He imagines the perfect machine. No friction, no wasted heat, just a hot bar, a cold bar, and a piston. He runs the math on a cycle. The gas heats up and expands, pushing the piston. Work is done, then you cool it down to reset the piston. Even in this magical, perfect, friction-free imagination land, Carnot realizes something devastating. You cannot reach 100% efficiency. It is physically impossible. You always have to dump some waste heat into the cold side to reset the cycle. You can't just turn heat into work without paying a tax to the universe. That tax is entropy. This realization was bigger than steam engines. It was the birth of the second law of thermodynamics. Energy spreads out. Always. It never spontaneously concentrates. Think about a hot cup of coffee. Leave it on the counter, it cools down. The heat spreads into the room. You never see a cold cup of coffee suddenly suck heat out of the air and start boiling, do you? But why? The laws of physics works backwards and forwards. If you zoomed in on the atoms, they're just bouncing off each other. If you reverse the film, the bounces would still obey Newton's laws. So why does the coffee never spontaneously boil? It comes down to pure, brutal probability. Imagine I have a Rubik's Cube. There is only one state where it is solved. One perfect, low-entropy arrangement. Now, if I close my eyes and start twisting it randomly, what happens? Every turn moves it away from that one perfect state into one of the quintillions of scrambled states. It's not that the cube can't solve itself by random chance. It's just that there are billions of wrong ways and only one right way. The universe is that Rubik's Cube. It is constantly scrambling itself. Let's scale this up. Take 2 metal bars. One hot, full of energetic jittery atoms. One cold. Put them together. The energy packets start hopping around. Could all the energy randomly hop to the hot side and make it hotter? Theoretically, yes. But the odds are so astronomically low that you could wait trillions of years and never see it happen. In a real object, you have trillions upon trillions of atoms. The statistical probability of heat flowing from cold to hot is effectively zero. This is why entropy always increases. The universe is moving from the unlikely state of order to the overwhelmingly likely state of mess. This sounds depressing, right? Everything getting messy, forever? But wait, look around you. You are a highly ordered structure. Your brain is a complex machine. Skyscrapers, microchips, ecosystems, these are pockets of intense order. How does that fit into a universe that demands chaos? It's simple. We are chaos factories. To create this tiny pocket of order that is your body, you have to create a massive amount of disorder in your environment. You eat food, you burn fuel, you radiate heat. You are paying for your existence by accelerating the heat death of the universe. Life doesn't break the second law. Life is the most efficient way to execute the second law. Nature loves life because life is really good at destroying order. This leads us to the biggest question of all, the origin of everything. If entropy is always increasing, that means yesterday it was lower than today, and a billion years ago it was even lower. If you rewind the tape all the way back, the universe must have started in a state of insanely, impossibly low entropy, the Big Bang. But wait, the Big Bang was a hot, dense soup of particles. That sounds high entropy, doesn't it? It sounds mixed up. Here is the missing piece of the puzzle, gravity. When gravity is involved, spread out is actually unnatural. Gravity wants things to clump. It wants to crush matter into stars and galaxies. So, that smooth, uniform distribution of the early universe? That was actually incredibly low entropy because gravity hadn't messed it up yet. As the universe aged, gravity pulled things together, stars ignited, energy was released, and entropy skyrocketed. We are just riding the shockwave of that initial explosion of order. And where is all that disorder going? Black holes. This is where it gets mind-bending. For a long time, physicists thought black holes were just pits. But then Beakenstein and Stephen Hawking dropped a bombshell. Black holes are the ultimate storage lockers for entropy. The supermassive black hole at the center of our galaxy contains 1,000 times more entropy than the entire early observable universe combined. Almost all the entropy in the cosmos is locked up in these monsters. And even they aren't eternal. Hawking proved they radiate over unimaginable timescales. Numbers so big they don't even make sense to the human brain, like 10 to the power of 100 years. Black holes will evaporate. They will spit their energy back out into the void. This brings us to the end, the heat death. When the last black hole vanishes, the universe will be a cold, dark, expanding bath of nothing. No temperature differences, no energy flow, no life, no time. Because time is just the measurement of things changing, and in maximum entropy, nothing ever changes again. The arrow of time will dissolve. But don't have an existential crisis just yet. We are living in the Goldilocks zone of time, the glorious middle. We aren't in the boring, high-order beginning, and we aren't in the boring, high-chaos end. We are in the complex phase, like milk swirling into coffee. Before you mix it, it's boring. After it's fully mixed, it's boring gray sludge. But in the middle, when the swirls are happening, that is where the beauty is. That is where the complexity happens. That is where we are. If you want to keep exploring the wildest stories in science, make sure to smash that subscribe button and ring the bell. Join our community of curious minds. I'll see you in the next one.